In this video, we're going to look at topic 75, example 1, equations. And we're going to work on using the quadratic formula to solve these equations. The question is, what are the solutions to the equation? And then in part A, 3x squared minus 4x minus 9 equals 0. So we want to pay attention here, and we're given this formula, which is the quadratic formula, given some kind of explanation with it. So it provides the solutions of the quadratic equation, ax squared plus bx plus c equals 0, for a does not equal 0. Right, because if a equals 0, then it's not a quadratic. So the nice thing about the quadratic formula is that you can use it to solve any quadratic equation. There's nothing that you have to make sure is true, like in factoring, right? We can use factoring, but only if the problem is factorable. We can use completing the square, but completing the square only works, well, it'll always work, but we have to create a certain scenario for it, right? There's a lot of work kind of outside of the place. The quadratic formula, all you need to do is make sure that your equation is equal to 0, and then you can start using the quadratic formula. The first thing you want to look at is you need to label or state what the a, b, and c values are. So in this equation, 3x squared minus 4x minus 9, we would say that a is equal to 3, b would be equal to negative 4, and c is equal to negative 9. So we're getting those numbers from right here, right? A, and then we have our b value, and then finally our c value. The most important part of finding a, b, and c is that the equation has to be equal to 0. If it's not equal to 0, then your a, b, and c values will be inaccurate, so make sure that they are correct. Next, I'm just going to rewrite the formula. Negative b plus or minus b squared minus 4ac over 2a. And the next step is probably the most important, is substitution. If you don't substitute the numbers incorrectly, then obviously you're not going to get a correct answer. So what we want to do is we want to be very careful, take your time with this step, and I'd always recommend using parentheses every time you're substituting. So what I need to do is I need to place b here and here, my a value, and my c value. Okay, so let's start with that. So I have negative 4 plus or minus negative 4 squared minus 4 times 3 times negative 9. And all of that will be over 2 times 3. All right, so let's highlight some of that so we know where these numbers are coming from. And negative 9, 3. So again, I always recommend when you're substituting to put parentheses around the numbers that you substituted in. That'll really come into play, especially with your b values, because you could have negative negatives, which will turn to positives, and you're squaring b within the square root. So what's really important is that you have that negative in parentheses. That's probably one of the more common mistakes, is squaring when you do b squared. So I'm just going to go step by step here and now slowly simplify this and eventually get our solutions. So we have x equals negative 4 will become positive 4. We'll keep the plus or minus. Negative 4 squared is going to be 16. Be very careful typing that in the calculator. If you don't use the parentheses, you're going to get negative 16. We're squaring the entire term negative 4. Next thing we have to be careful of is this negative 4 times 3 times negative 9. So I have a negative 4, a positive 3, and a negative 9. That tells me that this will wind up being positive because I'm multiplying two negatives. 4 times 3 is 12, and 12 times 9 would be 108. Just use a calculator to avoid mistakes. And 2 times 3 is 6. So I'll continue that up here. So x is equal to 4 plus or minus 16 plus 108 would be 124. And we'll keep that all over 6. There are points in this problem where you would be done here. What you do need to check for, though, is you need to see if you can simplify the term, simplify the radical. So we need to look at simplifying this entire radical. Sometimes you can, sometimes you cannot. This time we can. So we would have x equals 4 plus or minus. I want to look at square roots that go into 124. That would be 4 times 31. And that would be over 6 still. Right, because 4 times 31 is 124. So x equals 4 plus or minus. The square root of 4 is 2. So let's just highlight that so we know where that came from. And then the radical 31 stays. All of that would be over 6. Again, this is another step where you could potentially be done at this step, but you won't always be. Sometimes you will, sometimes you won't. But the next thing you need to look for is to see if you can reduce this. In this case, the 4, 2, and 6 all have a common term that goes into them. We can divide them by 2. So I would actually reduce all of this, and that would become 2 plus or minus radical 31 over 3. So here we're going to simplify. You can't always simplify, but again, in this case we could, so we'd want to simplify that. There's nothing else I can do with that. I can't divide anything out. I can't simplify radical 31. So this would be my solution. We can actually write this as 2 separate solutions if you wanted to. You could write 2 plus radical 31 over 3 and 2 minus radical 31 over 3. But there's really no reason to separate them in this case, so I would recommend just leaving them together with the plus or minus. So in quadratic formula, just plug your numbers in, be careful, take it step by step. Definitely do not rush through these problems. So let's look at example B. In example B, our equation is equal to 0, so we're good here. We don't have to move anything around. So I'm going to take my equation, x squared minus 9x plus 27, and I would label my A, B, and C values. Okay, so let's try to find or use the same colors. B is going to be -9, and C is 27. I can't stress how important it is that you are careful with your signs. All right, if you have the wrong numbers substituted, you're going to get the incorrect answer. All right, and you might do the whole problem correctly, but if you substituted incorrectly, then all that work was to get an incorrect answer. So here x is equal to -9 plus or minus -9 squared minus 4 times 1 times 27. And all of that would be over 2 times 1. All right, we may run out of space here, but we'll figure this out. So x is equal to 9 plus or minus -9 squared would be 81. We have a -4 and the rest are positive, so this will be a negative number. 4 times 27 would be 108. I'm doing my math correctly, which hopefully I am. Let's just double check that. Yeah, 108. We then divide that by 2. All right, so let's keep going. So x is equal to 9 plus or minus 81 minus 108 is going to be -27. So we do have a negative inside of our radical, so hopefully remember how to deal with complex numbers. So I'm going to simplify this. Again, there are times where you might be done at that step, but -27, we can simplify that, so we definitely need to make sure we're doing that. So this is going to be 9 plus or minus. Actually, let me just go back real quick and show where I substituted. C value was 27. And what are we missing? We're missing the A value. So A was that 1 and 1. Okay, now we can continue on. So this radical -27, we can simplify that. So what I'm going to do is I'm going to break that up into -1, 9, and 3. And all of that will be divided by 2. So x is equal to 9 plus or minus. So the -1, remember square root of -1 is I. The square root of 9 is 3, so we're going to write the 3 outside, and radical 3 stays. Let me rewrite that a bit neater. So this would be 9 plus or minus 3i radical 3 over 2. Now in this case, again, like the last one, we should check to see if we can simplify anything on the outside. The 9, the 3, and the 2 do not have any common divisors, so nothing goes into all of them. So we're going to be done there, and we'll leave it at that. So we get 9 plus or minus 3i radical 3 over 2. Here you would have complex solutions, right? We'd have non-real solutions with that with the I term in there. So hopefully just watching these two examples gives you a pretty good idea of how to use the quadratic formula. Again, the nice thing about the quadratic formula is it always works for quadratic equations. You just have to make sure the equation is set equal to 0, and then be very careful substituting your a, b, and c values in. If you're careful with it, you should get these correctly. Sorry, you should get these correct. Having trouble speaking just now.